Hello students, how are you? Today we are going to discuss some numericals and which will be a continuation from the previous session. And I have the group, I have sent you few numericals. I have sent you some theoretical questions also. You go through all of them, not all of them, how we are teaching according to that. If you'll proceed further, along with that only you will go. Okay, but I have sent few numericals also, and some selected problems of that I'll discuss in this session, and gradually we'll see whatever your doubts are, especially we will put to me personally, and I'll reply them. And by replying to them, I'll make some more videos. Fine. Okay. So you have those questions open with your in your end, so that I need not repeat those questions again. For example, I'm taking assignment number 1.2. Okay. You keep open those assignments so that you can follow it properly. Of that, the first numerical: how much positive and negative charge is there in a cup of water, supposing that the cup contains 250 cc of water. Okay. So as I have said you already, whenever we read a numerical, basically what is given in the question and what we need to find out. If everything we can list systematically, then halfway we have understood the question already, and we are in a position to proceed with that. So in the similar fashion we'll proceed. What it is asking now is how much positive and negative charge is there in a cup of water, supposing that the cup contains 250 cc of water. Okay, what is given in the question? 250 cc of water, right? And 1 cc is 1 gram, you know that, right? So, or 250 gram of water. Now this question is basically depends on the Avogadro's number, the concept what you have gained from chemistry side. What it says is, what is the gram mole, what is the atomic weight of H2O? It is 1 plus 1 plus, what's the atomic weight of gram or mole of oxygen? Is 16, is equal to 18 gram. So what it says, the Avogadro's number is 18 gram of water contains 1 mole of H2O molecules. And 1 mole means what? It's a huge number, that's called Avogadro's number, which is equal to 6.023 into 10 to the power 23 numbers of H2O molecules. In every 18 gram of water, there is 6.023 into 10 to the power 23 number of water molecules. Fine. Then in 250 gram, how many molecules will be there? Implies that in 250 gram of water we have how much? 250 by 18 moles of oxygen, moles of H2O molecule. Yes or no? Then so here I am writing from here, let us say, then these many moles, in 1 mole these many number of 6.023 into 10 to the power 23 number of molecules are present, right? So what is the total number of therefore number of H2O molecules in 250 gram of water is equal to how much? 250 by 18 into 6.023 into 10 to the power 23 number. Now, is it visible to you? Later on, if you want, you can pause the video, take it a little back and see again. After this, I cannot write. That's why I am just erasing this part. So, in 250 gram of water, these many molecules are present. Now see, in one molecule of H2O, how many electrons are there? One electron contains some certain amount of charge. So how many electrons are there? 1 plus 1 in hydrogen 1, in another hydrogen 1, and in every outermost of every oxygen there are 8 electrons. So there are 10 electrons in every molecule of H2O. Now if these many number of molecules are there, multiplied by 10 times the number of electrons will be there. Therefore, number of electrons present in 250 gram of water is equal to how much? 250 divided by 18 multiplied by 6.023 into 10 to the power 23 multiplied by 10, these many electrons. Now, one electron carries a charge of 1.6 into 10 to the power minus 19 Coulomb. Charge of one electron is equal to 1.6 into 10 to the power minus 19 Coulomb. Okay. Now since we are starting, the length is measured in a meter, like that how the charge is measured in a Coulomb. Right now you assume this much, then I'll explain you in another video. Let us say what 1 Coulomb is, how much is said to be 1 Coulomb, all those details I'll tell you. But to go with this numerical, let us say charge of 1 electron is measured to be 1.6 into 10 to the minus 19 Coulomb. We will assume it, we'll take it as one information. Okay. Then if the number of electrons present are these many and one electron carries this much of charge, then total charge in 250 gram of water is equal to how much? 250 by 18 multiplied by 6.023 into 10 to the power 23 multiplied by 10 multiplied by 1.6 into 10 to the power minus 19. So this much of Coulomb is the answer, and the answer is with you, which says 1.338 into 10 to the power 7 Coulomb. Solve this, it comes 1.338 into 10 to the power 7 Coulomb is the answer. Okay, we have to solve this much. So see, I am not very satisfied. If there is some question I need to take, but you apply your brains, and if some question still persists with this, whatever we are discussing over here, the numericals part, you ask me, I'll take, as I said you in the group, I'll take some doubt clear classes, and in the doubt clear classes I'll be discussing only those points which you have asked, and there will be several doubts of course, but of them I'll be discussing selected questions. Okay. Now this was the first problem of the assignment 1.2. Second problem is a similar one I am leaving for you, and I'll be discussing the third problem now. Well, third problem reads, a free pith ball P of 10 gram carries a positive charge of 5 into 10 to the power minus 8 Coulomb What must be the nature and magnitude of charge that should be given to another pith ball Q fixed 7 cm below the former ball so that the upper ball is stationary? Okay, so okay, I erase that thing. Assignment 1.2. Now question 3 I am discussing. 2 I left for you homework. Now what this question says, a pith ball P of 10 gram, there is a ball P 10 gram, carries a positive charge of, okay, charge is given, charge of plus 5 into 10 to the power minus 8 Coulomb. Okay, what must be the nature and magnitude of charge that should be given to another pith ball Q fixed 7 cm below 7 cm below the former ball so that the upper ball is stationary? Okay, fine. Now P has to be stationary. Now what forces the P is experiencing? One force, naturally its own weight downwards, which is equal to mg, and another force, see, if this is positive charge and if we are taking, let us say we don't know what is the charge on Q, let us say that is plus Q. If plus Q is there, then plus plus will be repelling each other, so due to P there will be a force on P due to Q, which will be upward, and mg is downward. Now if we want to keep a P as a stationary, then for equilibrium of P, FPQ must be equal to mg. Yes or no? Implies that mg, mass is given to be 10 gram, but everything to we should maintain in a SI system of units. So 10 into 10 to the power minus 3 kg m into g. G is another 10. I put mg. I am writing mg first. Mg is equal to FPQ. So mg, I wrote m. This much is m to g is equal to, what is the repulsive force? That's a Coulomb's force of repulsion we have calculated already, that is 1 by 4 pi epsilon naught q1 q2. So q multiplied by this charge is given already. How much is that? 5 into 10 to the power minus 8 q1 q2 by r square. Now 7 cm means 7 into 10 to the minus 2 meter. So 7 into 7, 49 r square. I am saying this is r, this is 49 into 10 to the power minus 4 meter. Now implies that in this equation only q is there, right? You find out. Now I'll tell you one thing to remember. From experimentation it is found that 1 by 4 pi epsilon is equal to, let me say this rough, 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9. This came from experimentation. And what is that experimentation? See, this is rough. We are saying this like this. So force is equal to 1 by 4 pi epsilon naught q1 q2 by r square. This is the Coulomb's law. Implies that from here what we can find, 1 by 4 pi epsilon naught is equal to fr square divided by q1 and q2. Yes or no? Now let us say we are taking two charges. q1 is 1 coulomb only and q2 also is 1 coulomb only. Two 1 coulomb charges we keep at a distance 1 meter from each other. Then r becomes 1, this becomes 1, this becomes 1. F becomes 1 by 4 pi epsilon naught. Yes or no? Okay. So 1 by 4 pi epsilon naught is equal to, numerically it is equal to the force experienced by two 1 coulomb charges separated by 1 meter distance from each other. Yes or no? So by doing this experiment, 1 by 4 pi epsilon naught is equal to what is the force experienced, it can be calculated. It is calculated that way, and it is found that 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9. Okay, so here for 1 by 4 pi epsilon naught, we can put the value 9 into 10 to the power 9. It's always okay. So this is how this become 1 by 10, right? 10 to the power minus 3 is by 1000, 100 by 1000, 1 by 10 is equal to 9 into 10 to the power 9 cube into this is 50 by 40, it's not 50, so 5 into 10 to the power minus 8 divided by 49 into 10 to the power minus 4. So in this question q only is there, q we can find out, and that you will do at home, and the q comes to be, the final answer q comes to be 1.067 into 10 to the power minus 6 Coulomb. Fine. Now what assignment I have given, it is the same assignment, assignment 1.2, and question number 5 we will take up. Again 4 I am leaving for you. You think yourself, apply your brains, and after applying still you don't get, I am still there to solve again. Okay, so all the questions discussing in this video is not possible. Anyway, whatever doubts remain, those things we can make another video whenever time permits. Okay, now refer to assignment 1.2 question number 5, which says two small spheres each of mass m kg and charge q coulomb are suspended from a point by insulating threads, each of length L meter but negligible mass. If theta is the angle which each string makes with the vertical when in equilibrium, show that q square is equal to 4 mg L square sin square theta tan theta 4 pi epsilon naught. Okay, good question. It is a theoretical question only. What it asks is, two small spheres each of mass m kg and charge q coulomb are suspended from a point by insulating threads each of length L meter. Okay, so two spheres each of mass m kg and charge q coulomb, both are having charge q. Coulomb. See, Coulomb is the SI unit, that's why I am not writing, and m kg, all are in SI units only, so I am not writing the units to make the diagram look clearer. Suspended from a point by including threads of length L. This length is L, length of the thread is L meter, but negligible. If theta is the angle which each string makes with the vertical when in equilibrium. Okay, when in equilibrium, each string makes with the vertical an angle of a theta. This is theta, so this also is a theta. Okay, so prove that q square is something. Okay, now basically you take any one of this. Let us take this and we'll draw a free body diagram of this mass. So what forces are experienced by this mass? Remember free body diagram concept from last year? We were showing all the forces acting on a body, considering it to be a point mass. Now downwards there is its own weight of force is being acted upon. Towards the right, see, if this is the two like charges, they will repel each other, yes or no? So this will be repelled this side, this will be repelled this side, but this body we are not considering now, this we are considering. So there will be F, some electrostatic force of repulsion will be there, yes or no? Fine. Then consider the triangle, this, instead of saying this, so this, let me take some names. This is, let us say, A, this is B, this is C, let us say. Now consider the triangle OAC. In triangle OAC, Don't you think that tan theta is equal to this side by this side? And since these balls are in equilibrium, this side is represented by this force and this side is represented by this force. Fine. So tan theta is equal to Fe by mg. Fine. So from here what I can say is tan theta multiplied by mg, tan theta into mg is equal to Fe, and Fe is equal to what? According to Coulomb's law, 1 by 4 pi epsilon 0 q1 q2, q into q, that is q square by r square, the square of the distance between them. What is this distance? Now don't you think that this much is L sin theta? See, in the triangle OAC again, this is L. So this much is L sin theta, this much is L cos theta. Remember, it can be resolved into two components. Now this much is L sin theta, this much is another L sin theta. So 2L sin theta is the distance between the balls. Now Q1, Q2 by R square. R is the distance between them. Distance between the balls are 2L sin theta. 2L sin theta whole square. Is it visible now? 12 sin theta by r square implies that tan theta into mg is equal to q square by 4 pi epsilon naught into 4l square sin square theta. Fine. Now what it asks to prove, q square is equal to 4mg l square sin square theta tan theta into 4 pi epsilon naught. So q square is equal to, take it this side, you got exactly this what it is asked to be proved. Yes. Okay. So as I said, we will continue with this format, and you will tell me what is the problem in this kind of format, or if somehow it can be improved or something like that. We will do it as on the go. And now I want to give a general understanding of how this assignment system, everything will work out. Okay, there will be one assignment 1. Assignment 2 will start with chapter 2. So chapter 1, then chapter 2 will be there. In fact, both are electrostatics, but chapter 2 will be there. That will be assignment 2. Now that also will be having two parts, 2.1, 2.2, and this will continue in the similar format for all the chapters. Every chapter will be having that assignment, and that will be having 2 parts of the assignment. And what are those 2 parts? The first part will contain most of the 99% of or 95% of the theoretical questions and few numericals, and that numericals also will be theoretical numericals only. Theoretical numericals in the sense it will clarify, it will be a numerical, but it is a purpose of that will be clarifying the theory only. Okay, then there will be another assignment 1.2, which will be purely numericals. Okay, and of the numericals, so we will be having various standards, like we'll be solving some CBSE board level numericals, then JEE main level numericals, and then entirely high level, advanced level 2-3 problems also will be doing from every chapter. Fine. So what I have given till now is of assignment 1.1, I gave it completely. Okay, so thank you everybody, I'll be waiting for your feedback.